Let's talk about design by contract versus design by capability. These two are fundamentally two different ways to design software, mostly influenced by the programming language we choose to implement. Most mainstream languages like Java, C Sharp, and C++ often lead us toward design by contract. On the other hand, languages like Smalltalk and Ruby often lead us to design by capability. Then there are languages like Groovy which provide both of these capabilities. Well, the reason predominantly is statically typed languages often lead us towards design by contract. Dynamically typed languages often lead us towards design by capability. Well, in order to understand what the key differences are, the strengths, the benefits, and some of the consequences of using this, let's dive into these two ways of designing software. Let's first talk about interfaces. What's an interface? An interface is pretty much an abstraction, but it's a collection of methods. Interfaces often don't allow any implementation in them. Well, default methods in Java 8 does provide implementation, but those get really mixed into the abstraction that inherit from this interface. So for pretty much we can say interfaces do not have any implementations in them. Even in C++ we have interfaces. They come in the form of the pure abstract base classes, where abstract base classes only have pure virtual functions. In the case of Java and C Sharp, we have interfaces specifically defined using the keyword called interface. Interfaces are a collection of methods, so basically we have a bunch of things we can do, but an interface itself doesn't do any of those things. It's for the implementer of the interface to really implement that. When a class inherits from an entity, an abstraction, we call it inheritance. But when a class inherits from an interface, we call it interface-based inheritance. A class can inherit from multiple interfaces. In languages like Java and C Sharp, a class can inherit from multiple interfaces, but it can only implement at most from one class. So we often say that these languages support multiple interface-based inheritance, but only support single implementation inheritance. Well, let's understand what the benefit of this particular interfaces are and how we can use them in reality. Interfaces pretty much serve as a contract. Before you make a particular call, before you even compile the code, you are asking for this contractual agreement. So this is like signing off some papers and saying, here we meet these expectations very rigorously. Design by contract is actually fairly good for a lot of different things. We cannot imagine fruitfully implementing plugins, especially in large enterprise applications, if we really don't have the design by contract capability. With design by contract, compilers can verify that a piece of code meets a certain expectations. For example, in a plugin architecture, you might have a plugin architecture for, let's say, modeling a refinery. You might have different unit operations of the refinery modeled. You have heat exchangers, for example, flash over here, reboiler over here, and all these different devices and equipment putting together. But a third-party company who is implementing the particular solution may want to customize and implement their own unit operations or equipment. And when they come along to implement it, there are certain contracts we need to provide. For example, the tool, the application we developed must be able to integrate with their specific components. It must be able to save it. It must be able to display the values appropriately. So there are these contractual bindings through interfaces. Ability for you to call a command of save and tell where to save, and the object can decide what to save. An ability for you to tell to display where to display, but the object decides what to display. And other various contractual things we would implement as an interface. We do this all the time in our daily work. For example, you are ready to pay for a service, you ask them, what kind of a payment do you accept? They may accept a check, they may accept a cash, they may accept a credit card, but these are very strict contractual boundaries between the service provider and the receiver of the service, and or the service payer and the receiver of the payment. So the point really is there are these contracts that we work with often. Let's look at one of the examples of benefits of such a contract as it streamlines writing code very nicely. Let's look at this one example here. I've got a class called sample. Let's create something very, very simple here. Let's go ahead and say the sample extends from a JFrame for a minute. So I have brought in the swing J frame here into the context, and I'm going to create an object of this frame. So J frame over here, we'll call it frame equals new sample. And once we create it, we'll say frame.set size. And in this case, we will set the size to, let's say 100 over 100. And then we'll ask the frame to become visible at this point. So we can see that we created a frame. But notice in this case, a frame is an abstraction, but we are communicating through a very well-known interface of this abstraction. We know that going to a frame, we can call methods like set size and set visible. But this only goes further as we begin to interact with it. For example, we can override a function like frame init, for instance. This function allows us to initialize a frame. So for example, we could say over here, button equals new J button, for instance. We could create a button called click, for instance. And then we could say get content pane dot, we could say add, and then we could add the button to it. But of course, we need to know what this button is. We'll create a field for the button called the J button. And then of course, we have created this button. So if we go ahead and run this little example here, we can see that a little window pops up with a click button sitting in there. But I want to operate on the click button. Well, clearly, I did not write this J button. The J button is actually part of the Swing API. Well, but I want to go to the J button and say, knock, knock, J button. When I click on you, I want you to do certain operations. Enters a contract. So the J button says, if you abide by a contract, then when you click on a button, I will notify you when such an event happens. So in order to do this, I'm going to simply say button.add event mouse event listener. So mouse listener. And that requires a mouse listener. As you can see here, it says, give me a mouse listener to work with. Now the mouse listener I'm going to provide here, I'm going to say handle mouse, for example. That is all I'm going to say. I could have written this as an anonymous inner class here, but I'm going to write it as a separate inner class rather than an anonymous inner class. So I'm going to go ahead and implement the mouse listener as a mouse handle mouse. But notice I'm going to create it as an inner class. But the minute I say create as an inner class, the IDE was smart enough to realize that I am sending an instance of mouse handle mouse to the mouse listener function, and that requires it to comply with the mouse listener interface. So that exactly is a contractual binding we are talking about. It is very easy to see what is needed for you to implement this particular contract here. So if a mouse handle mouse object has to be sent to the add mouse listener, then it has to implement the mouse listener contract. So interfaces serve as a contract in applications, as we just saw here. Now I can easily implement these methods that are part of this contract. And so as a result, you can see in this case, we have a mouse clicked. And of course, in the mouse clicks, I could say J option pane dot, and we could say, for instance, we could provide a show message dialog. And then in this case, we could say the mouse event is what we are receiving. So we'll say mouse event. And I'm going to say, I've received a mouse event. I'm going to get the component from the mouse event and say you clicked over here as the value that I would like to display right here when the mouse gets clicked. So now when we run this code, you can see we can click and it immediately says you clicked, which is the message we displayed, and you can see that it responded to it. So this is the design by contract where it becomes extremely easy to communicate between different parts implemented and developed independently. Now the J button has a contract that says if such an event happens, I can send the event to you as a mouse event and tell you that something happened. The mouse event itself is packed with a lot of different details, for example. So if you go to the mouse event, you can ask for what was clicked on, and you can get details of the click itself. You can get the location on which the click happened, and you can get the X coordinate, the Y coordinate, and so on. So a slew of information becomes available, but all that comes to us through the contract called the mouse listener contract. The mouse listener contract says we are supposed to implement the mouse click, the mouse pressed, the mouse released, the mouse exited, and all of these different methods are expected from the mouse listener. Now, of course, you could also say, well, I don't have much to do for a lot of these methods. These are all left as a dummy operation. So instead, you could simply say extends mouse adapter, for example. Then you don't have to specify these methods which are blank over here. As you can see, we can remove it and the code is still happy to work through, not a problem. On the other hand, if you were to implement, in this case, rather than extending the mouse adapter, if you were to simply implement, let's say implements mouse listener one more time, notice it gives us an error because you haven't fulfilled the contract of this interface. We haven't implemented these other 4 methods that it was expecting. But if we do go ahead and implement the other 4 methods, notice that it no longer complains because those 4 methods have been implemented. So that is one of the biggest benefits you see of the design by contract is tools can verify, the compiler can verify, the tools can assist in putting 2 parties together, and so they can lock in and work with a certain expected predefined contract. So as a service provider, you can dictate terms. As a service receiver, you can abide by those. And also you can negotiate a contract to say, here are the piece of information I need, and here are the piece of information you need to provide, so it can work both ways. So you could be implementing this code and you could say, I need these pieces of information for my code to work. And then of course you can find providers who can provide those kinds of information. And of course the compiler can verify to make sure that the endpoints are meeting properly. So you don't get a compilation, you don't get a runtime error, you can verify at compile time. So as a result, if you notice in this particular example, if I were to create a mouse listener, handle mouse, for example, but if I don't conform to that interface that you see here and provide my own arbitrary implementation, whatever that could be, then what's going to happen is the compiler, way before we could ever run this code, the compiler immediately jumps in and says, I'm sorry, I cannot pass an instance of handle mouse to this function because it doesn't conform to the contract, the expectation that is laid out in this code. So we can see the benefit of that really clearly. However, as much as this is very powerful and useful, there's no doubt about it, but there is a case where we cannot assume a guarantee, for example. Now, clearly this would be a poor behavior, but notice in this particular case, when we have the mouse clicked function, rather than implementing that function in the mouse clicked, what if we were to simply do something else? For instance, we say throw new, and then I'm going to say runtime exception, you clicked, and this is a mad click implementation. But when we run this code, you can see if we click on this, the code is going to fail. You can see the error being reported right here and the code miserably failed. And so that is an example where we are implementing an interface, but clearly violating the contract at the code level in a way that the compiler cannot really verify, at least in the languages that we are talking about here. I'm sure there are languages where a compiler is smart enough to go deep down and verify these things, but most of the mainstream languages merely stop at that level and then say, SOL, I hope you know what you're doing. So the point is that the contract is very powerful, very useful for compile time verification. It's very useful for tools to figure out what the contract is and help us to implement the code. It also becomes very easy for programmers to communicate with each other and dictate these contracts across. So overall, the collective good of this is definitely there, and we definitely should make use of the design by contracts as much as we can, and we do in quite a number of systems and applications. However, the design by contract does carry a burden for us. So to understand what this burden is, let's take a look at yet another different example here. Let's say we are interested in a very simple example of asking a help to a man. So we have a big furniture here I want to move. I could find a man standing over there and say, excuse me, sir, could you please help me move this desk or furniture from here to there? Well, I could ask for help of any man in the room to help me to move this particular furniture. So we could say, for instance, we have a class called man, and we could have a method on the man. For example, we could say help, and this could be an implementation. We will simply output a man helping, for example. So if I were to create an object of man, so we could say man equals new man, and then I could say man dot help, and we could ask for help from a man. Well, that's great so far, but let's say for a minute, I'm going to look around and say, can a man help me? If there's a willing and able man, surely the man is going to help. But the ladies in the room completely are going to ignore me because obviously I said, can a man help me? I did not ask a woman to help me. So how rude. I should definitely seek help from anybody who is willing to help me. So the point is, I don't want to simply say, ask for help from man. Well, if I were to roll this code into a separate method, for example, if I were to say, let's say we have a method called seek help, and the seek help method takes a man over here. I'll call it the helper, and I'm going to say helper dot help over here, and I've asked for help from the man. So now I could simply call this method seek help, and I could say from, and I could say man over here. So that's my seek help from method. So if I run this code again, you can see that code works. But what if we were to create yet another class here called women, and then of course this also contains a method called help, and within this method I'm going to say women helping, which is a different implementation, but nevertheless there is a help method in the women class. So now I'm going to go ahead and create an object over here. Let's say this is man Bob, and I'm going to send Bob over here, but I'm going to create over here yet another object which is woman. We'll say Sarah equals new women, and I'm going to say seek help from Sarah, but notice the compiler gives me an error of incompatible type. That is because I cannot send a woman where a man is expected. So as a result, we have incompatible interfaces. I cannot send a man where a woman is expected or a woman where a man is expected. So I cannot really treat these independent of each other. I cannot simply say, I don't care what the type is, I want to pass it. This is designed by contract, as we can see here. The seek help from method has established a contract in statically typed languages that it is expecting a man to be provided in this particular case. How do we solve this particular problem? Enters the burden of contracts. So while contracts are definitely a great idea, where they do get complicated is they enforce a contract all the time. So while the contract is very useful for us, we don't have the luxury of saying, here I want to apply the contract and here I don't want to. We don't have that luxury. We have to follow by the contract. So one way to fix this problem is we could say class human, for example. We could even make this an abstract class, and then the human could have a method over here called the help method, which is also abstract. So once we implement an abstract class, and we'll make this method an abstract method as well. So notice now we're back to the error on Sarah, but we will say that man extends from human, and women also extends from human as well. And of course, we could mark this with override if we really wanted to, but that's optional in Java. Now we can go back here and say human helper, and then we are asking the help from the human. So what did we have to do to make this work? When we introduced a new class called women, we had to raise the level of abstraction to a human, and we had our seek help from depend on a human rather than depending on a man or a woman, because we could use them interchangeably. Well, that's great so far, but imagine that I'm in the beautiful wilderness and I have a wonderful, nice elephant sitting in the corner, and the elephant is more than willing and able to help. In fact, it can help much more than humans in situations. So I'm going to say I have a different implementation here where the elephant can help quite a bit. So this elephant is very eager to help us. So what I could do here is I could say elephant, and here we have our elephant over here. So our elephant, little elephant, one of my favorite movies is Jungle Book, and so we'll use Colonel Hathi from that. So we have a Colonel Hathi here equals new elephant, and of course we could ask the elephant to help us. So we could say seek help from, and we'll send Hathi to that. Well, in this particular case, of course, that still doesn't work because you can't pass an elephant where a human is expected. Now, a sinister thought may be to extend an elephant from human, but I'm sure elephants don't like that. So what do we do in this particular case? We are back to square one here. We are interested in seeking help, but we haven't quite defined the abstraction for that yet. We started with a man, then we discovered a woman could help as well, and then we discovered an elephant could help in this application. Now we are deciding to move towards an interface. So interface helper, and then of course this contains a method called help over here. Now we could even get rid of the human if we don't care about that particular abstraction, and then we could say implements helper in here, and likewise the woman can implement the helper one more time, and the elephant also implements the helper interface. Now, of course, the seek help from would take the helper as a parameter, and then we can, of course, pass any of those objects. Well, that begs the question, when we develop this class, what should we depend on? Well, jumping around to create interfaces from the get-go can complicate a system as well. So we have to be very judicious when to introduce interfaces and when not to introduce interfaces. But having an interface gives this flexibility, but it's got to be the right interface as well. And we don't want an application where there are way too many interfaces that are completely unnecessary, especially if the only object we're going to be dealing with are the objects of human. Then obviously the helper is not that necessary in this application. So we got to use our judgment where it makes sense. So that is the burden of design by contract, is that we have to really place the abstraction at the right level, the functions at the right abstraction level, and we may have to create interfaces to make things work properly, only merely to abide by this contract. So while contract is extremely beneficial, there are times when a contract becomes a hindrance where we have to create this monstrous hierarchy of things just to get things moving. On the other hand, in dynamically typed languages, we don't have to really go through that pain. This is where the design by capability comes in. Now, quickly to understand this, let's grab all this code we have here up to the elephant, and we will copy it here into this editor here. And then we will also go ahead and grab the function we have here, which is the seek help function. Let's grab that as well and copy it here. I'm copying it into Groovy right here, but let's also take all this code from here as well and copy it here into Groovy. And let's go ahead and run the code, and you can see the Groovy code still works. So Groovy supports just about everything that Java supports as well. So we can do design by contract in Groovy if we choose to. However, Groovy doesn't force a design by contract on us, unlike Java and C# and C++ do. Let's take a look at what that means to us, and let's go ahead and do that by only keeping the seek help from method over here. And let's come back to this in a second. Let's say man for a minute. We'll come back to this. But if we go ahead and create a class called man over here, and within the class man, I'm going to define over here the help method, and we will simply output, in this case, man helping. So that's the implementation in the man's help method. Now, when we create the seek help from, we said this is a helper, but let's quietly leave out the type information from here. Now what we could do here is we could simply come back and create an instance of man. So we'll say Bob equals new man, and we will call the seek help from Bob, and we will invoke that particular method. And you can see the code actually worked. But then we come along and introduce a class called women, and in this case we have a help method within the women, and we're going to print line and we will say women helping over here. And now notice I can simply say define Sarah equals new women over here, and then we could say seek help from Sarah. And notice we didn't have to change anything in the code. We didn't have to introduce an abstraction or a hierarchy, and that's because our seek help from says, I will simply work with any object you provide as long as the object contains a help method. So for example, tomorrow if we introduce a class called elephant over here, and this elephant is rather independent, has a help method, and in this case we'll say elephant likes to help also. And in this case, if I create a seek help from new elephant and pass the elephant, you can see the code still works. We didn't have to create an interface and refactor the code to create this hierarchy. So this is designed by capability. Now this only works as long as the object is willing and able and capable. So this is much like if I have a furniture over here, rather than saying can a man help or can a woman help, if I simply say could I get help to move this table or move this large furniture? A man could help, a woman could help. Well, an elephant standing around may come and help me as well, assuming the elephant is well trained and listening to me. So I could seek help from anyone, or any particular helper can come and help me as well. So this makes the code a lot more extensible. But of course, there's a downside to this. For example, if I have a class called Fox over here, and if I were to say, for instance, seek help from new Fox, you know that's not going to go anywhere, and it fails miserably. And the reason for that is the Fox doesn't have a help method, and as a result, the code failed. Now, in most dynamically typed language, there is a way to query and find out if a particular object does have the method you are expecting. So technically, you could say response to and query if there's a help method on the helper. And then if it does have the method, you could perform certain operations. For example, you could say helper.metaclass. For instance, we could say response to, and then you could specify help over here, and let's just print that value here just to see what it's telling us. And notice in this case we could ask for the information whether it is responding to this particular method or not. And of course the method we are expecting is the helper help method out of this particular object. So we could ask him if it responds to this particular object method, and you can see in this case it does, not on the meta class but on the object, it does have the help method. So we could do something along the lines of, if this particular method does exist, we could call the help method, for instance. Otherwise, we could say else print line, maybe we'll say, are you kidding, for example, right? So in this case, you can see it said, are you kidding for the Fox, but it did use the help for the other objects. But having showed how to use the response to, you got similar methods in Ruby as well. I highly recommend that you do not use this function, because it's a poor practice in dynamic type languages to query, but instead you expect that only objects that qualify for this enter this function. So you model and design the system in a way that you don't either have to check for this, because naturally the way objects are passed around will fit to this, or use proper automated testing to iron out these things rather than checking in the code. So the benefit of the design by capability is the design is very lightweight. You don't have to really build a complex hierarchy. So in general, in dynamic type languages, we can use design by capability instead of design by contract, and the hierarchy seems to be a lot more flat in general, rather than a deep hierarchy that often arises when we use design by contract operations. Also, it becomes a lot more easy to evolve the design in a design by capability. However, there are some downsides to this approach as well. One big downside is, how do we know if the code that we are passing around, if the object we're passing around is actually capable? Well, we don't, because an object may not support a particular function. It may be there, it could get removed, it could be rearranged. So in the case of design by contract, we clearly have a compiler verifying for us to see if there is this contract binding that happens really nicely. Well, nevertheless, even in Java, you could compile the code and come and remove it and throw the bytecode together, and the code would fail at runtime saying this method is not found. But in general, we do have the ability to compile the code together and ensure that this doesn't happen as much. But in the case of dynamically typed languages, the norm is there is no compiler to verify, or the compiler is very lenient, and as a result, it's our responsibility to make sure we send the right things. One way to ensure that is a proper clarity in design where objects that do make sense to be around are available within the reach. So we could do a better design to make better use of design by capability. Another way to make sure of this is to make sure that we have proper extensive amount of automated testing, because we don't even know the code is wrong until you actually run the code and you literally take that path of execution using those objects at runtime. For example, in this case, if you did not call seek help from using Fox, you would never get that error. So your code may be using Fox all over, but that fateful code may not get called in your development setting, but is ready to be called in production, and the code may fail miserably. So you definitely want to avoid cases like this, but the way to do that in design by capability is to have extensive amount of automation testing. So we often lose some and gain some. In the case of design by contract, we have such a good gain in that we have a contract verification at compile time, but the disadvantage is a little bit of a harder evolution of the interfaces, a rigid contract where you got to wear your suit and tie and sign this contract before you can get things moving. In the case of design by capability, it's rather very flexible. Hey, can you do this? Are you willing and happy to do this? Come on over if you can do this. So it's a very, very flexible, easy to evolve, very casual kind of design, but the risk is you may end up with an object that's not qualified, not able and willing, and the way to take care of that is through extensive automation testing. So without extensive automation testing, it's foolish to even attempt design by capability, and I would argue that it's foolish to do design by contract also, but the reasons are far less there compared to design by capability itself. So when you're picking up a programming language, some languages like Java enforce design by contract, some languages like Ruby and JavaScript enforce design by capability, and then there are languages like Groovy which allows both design by contract and design by capability, and you get to pick and choose where to apply what based on what your needs are. So make use of these two options where it makes sense. Don't have fear picking one or the other, as long as we can understand the key strengths and capabilities and the limitations, we get to choose what's the right tool for the job on our hand.